let's say this is you, and you issue a fixed rate bond with a par value of $1. All right, so what does this mean? If you issue a fixed rate bond, that means that you will be making fixed payments. Now, with this $1, you buy a floating rate bond. So you spend that $1 and you buy a floating rate bond. That means that you will receive floating rate payments. So this is a combination of two instruments. Now think about a swap. You get into a swap with another counterparty. Let's say that counterparty is B, where you are pay fixed and receive floating. On a plain vanilla interest rate swap, the notional principal is not exchanged. So you have a notional principal of $1. It doesn't make sense to give $1 and receive $1. So there is no exchange of notional principal. Now, from your perspective, whether you are looking at this picture or this picture, is there any difference? No. So we can therefore confirm that this statement is indeed correct. Sometimes you might see this statement written slightly differently, where you might issue a floating rate bond and buy a fixed bond. Then you are just talking about the picture of the other party. So this is an important concept because it is used as the basis for pricing. Now, what is the principle behind pricing? And again, I'll connect this with what I said earlier. What does pricing mean? It means coming up with that fixed rate. All right. And another statement we made was we need to come up with a fixed rate such that the value is 0 at initiation. So do we know the various floating rates? We do. So if this is a 1-year swap with semi-annual payments, then we'll have the 180-day LIBOR and the 360-day LIBOR. So we know the various rates. We need to figure out what fixed rate will make value equal to 0. How do we do that? Find the fixed payments that set the present value of floating payments plus a hypothetical notional principal of $1 equal to the present value of the fixed payments plus a hypothetical notional principal of 1. So what we are saying is the fixed payments that we are making, if the present value of these fixed payments is equal to the present value of the floating payments that we are receiving, then what is the value of the swap? The present value of what you are giving is equal to the present value of what you are receiving. Therefore, value must be 0. When you set up this relationship and calculate the fixed rate, that essentially means pricing the swap. So let's do that through an example. Consider a 1-year swap with semi-annual payments on days 180 and 360. The underlying is 180-day CIBOR. We are given the spot rates. These are annualized spot rates. So 180-day CIBOR is 9%, 360-day CIBOR is 10%. What is the fixed rate? Now, we talked about the fact that we need to find the present value of the floating payments and the present value of the fixed payments and then make them equal. So what's going on here? If you think about the fixed payments, so there is time 1 and time 2, take a notional principal of 1. So on a fixed rate note, let's say that you pay X at period 1. Period 1 is actually day 180 and period 2 is day 360. So you pay X and then how much do you pay at the end? It's 1 plus X. What is the present value of these cash flows? So you need to discount X back. Are you given the 180-day rate? You are given the 180-day rate. It is 9%. So when you discount X back, you should get X over 1 plus 0.09 over 2. Why over 2? Because 9% is annualized. This is 180 over 360. Notice that as we did with FRAs, we are using a 30-day per month, 360-day per year convention, and also we are using this method to de-annualize. So this is the present value of the first cash flow. What's the present value of the second cash flow? Remember over here the notional principal of 1 plus the same coupon payment. Why do I write X and X? Because this is a fixed rate bond. 1 plus X discounted at 1 plus 10%, so 0.1. So this represents the present value of your fixed instrument. What about the present value of a floating instrument? Now with a floating instrument, do you know the interest rate for this period? So you know 180-day CIBOR, which means that you know the interest payment over here. Do you know the interest payment over here? You don't. Why? Because the interest payment here is going to be based on the 180-day rate that is in effect here at this reset date. So you can't simply calculate the cash flows and take the present value because you don't know the cash flows. You don't know this cash flow. But what you do know is that for a floating rate instrument, at reset date, the value is equal to par. Alright, so the value is actually 1. You know that if interest rates go up, then this number will be higher and it will be discounted at a higher rate. Net effect will be that the present value of the floating rate instrument at each reset date is going to be 1. And we are assuming here that there are no changes in credit risk and so on. So simplistically, we'll say that the value is 1. So we can then say that this whole expression must be equal to 1. So we are setting the present value of the fixed payments to the present value of the floating rate payments, and that is 1. So we can solve for X. But before we do that, I'm going to just do something that the curriculum does, and it's a convention followed when we deal with swaps. We come up with present value factors. So 1 over 1 plus 0.09 over 2, this can be simplified into a discount factor or a present value factor. The curriculum calls it a discount factor. So I want you to come up with the discount factors. This, and I'll use a terminology that is slightly different from the curriculum, and I'll tell you why. Let's say that D1 refers to the first discount factor for a payment received at the end of 180 days, and D2 refers to the discount factor for the second payment. So come up with the discount factors and then solve for X. X will tell you that fixed rate for a 6-month period, and then you annualize it by multiplying by 2. So I want you to do that. Some of you might be confused about why the present value of a floating rate instrument is equal to 1 at reset dates. So I'll just clarify that through this simple example which is done in blue. Let's say that you have a par value bond with par value equal to 1, and this is a floating rate instrument that you issue at time 0. It's a 2-year instrument and payments are made at the end of every year. So on this particular bond, say that initially the interest rate is 10%. So you know the next coupon payment. On $1 par, the next coupon payment is 0.1, and this can be discounted back at 10%. But what about the coupon payment at the end of year 2? That is going to depend on the interest rate at the end of period 1, which is unknown. For simplicity, let's say that interest rate might be 9% or 10% or 11%. If the interest rate is 9%, then for a 2-year bond, what is going to happen at the end of year 2 is you will get back the par value of 1 plus interest of 9. Where is the 9 cents coming from? It's 9% of 1. And 1.09 is going to be discounted at 9%, which will give you 1. So on reset date, the present value is 1. What if the interest rates are 10% over here? Then the payment at the end of year 2 will be the $1 par plus 10 cents or 1.1. That discounted back at 10% is again 1. And finally, if interest rates are high at 11%, then the payment at the end of year 2 will be 1.11, and discounted back at 11% means that you have a par value of 1. So no matter what the interest rates over here, at reset date, the present value of the subsequent cash flow is going to be equal to 1. And this is extremely important to understand. So when you solve for x, what you should get is 0.0487. So 0.0487 represents the fixed payment every 6 months on a $1 principal. This is every 6 months. So if you need to give an annualized rate, you take 0.0487 and multiply by 2, you get 0.0974. So your fixed rate is 9.74%. So what we have done here is that we have priced this very simple swap. And this slide summarizes what we have just done. So what do we know at time t equal to 0? This is information that's given. 180-day CIBOR is 9%, 360-day CIBOR is 10%. You will notice that in many of the questions in the curriculum and in mock exams, you are given the discount factor. It is being assumed that you know how to calculate discount factor, so you will save a little bit of time. And just to make sure that you know how to do this, just in case you are not given the discount factor, where does this 0.9569 come from? 180-day CIBOR is 9%, so the first discount factor based on a payment that happens on day 180. So this is the present value of a $1 payment happening on day 180. So what's the present value? It's 1 over 1 plus 0.09 into 180 over 360, or simply divided by 2. When you do this calculation, you are going to get this number over here. And what about D2? The present value factor for a cash flow received at the end of the second period. There we'll have D2 equal to 1 over 1 plus 0.1, and then it's times 360 over 360, which is 1. When you do this calculation, you will get 0.9091. And what are we showing here? With fixed payments, we've calculated that every 6 months the payment will be 0.0487. So for a $1 notional principal, where your swap ends at the end of 1 year, you get, as in the fixed payments will be 0.0487 and then 0.0487 plus 1. What about the floating payments? Where do we get this 0.0450 from? The point is that at time 0, do you know the 180-day rate? You do. So the 180-day rate is 9%. You know, therefore, that on $1 notional principal, the first floating payment would be 9% over 2, which is 4.5% of $1 notional principal. So that's 0.045. But you don't know this payment. But as we've established, the present value of all these payments at time 0 for the floating rate instrument will also be $1. Now what I'm going to do is take the concept that we've just learned and generalize. There is an extremely important formula that we will arrive at, which will be used to calculate the fixed rate. If we take our simple scenario where we had a 1-year swap, so there was a payment at the end of 6 months and then a payment at the end of the year. We said that the fixed rate for a 6-month period is X. So what is a quick way of coming up with X? The curriculum just shows you the end formula but doesn't tell you very nicely where it came from. So I'm just going to show you where that formula comes from so that you can remember it more easily. So here is what we are saying. We know that we need to calculate X. All right. That's the fixed payment at the end of 180 days, and then at the end of the swap, you get the coupon payment X plus 1. We've also calculated the discount factor. So let us just say that the first discount factor is D1, and then the second discount factor is D2. So if this represents your fixed rate payments, then we can say the following, that the present value of these payments is D1x plus D2, the second discount factor, into x plus 1. This must be equal to the present value of the floating rate bond. And we've established that at time 0, the present value of the floating rate bond with a $1 principal is equal to 1. Right? So can we solve for x? So here is the very basic algebra. I have talked about where this came from. And then if you solve for x, here is what you get. 1 minus the discount factor for the final payment, which in our scenario is the second payment, divided by the first discount factor and the second discount factor. Now, we did this for a swap with 2 payments. What if you have a swap with 4 payments? So you will see this scenario in the curriculum quite often. I've seen either swaps with 2 payments or swaps with quarterly payments. So if you have quarterly payments, then what will you see? There'll be a payment or a reset date at 90, 180, 270 and 360. Now the X is the fixed payment at the end of every quarter. So what are those payments going to be? X, 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 and then X plus 1. So in my terminology, the discount factor is labeled as follows. So what does D1 mean? D1 means the discount factor associated with the first cash flow. D2 is the discount factor associated with the second cash flow. And then this would be D3 and this would be D4. The discount factors are all based on 1 unit of currency. So what is the present value for the fixed rate instrument? That is simply D1x plus D2x plus D3x plus D4x plus D4 into 1, which is simply D4. And then we need to make this equal to the present value of a floating rate instrument. What is the present value of a floating rate instrument where the par value is 1? That is simply 1. And here, when you solve for x, what you will get is the following. So x will be 1 minus d4 divided by d1 plus d2 plus d3 plus d4. So I hope you see the pattern. The pattern is that your fixed payment at every period is equal to 1 minus the discount factor for the final payment divided by the sum of all the discount factors. Alright, so we can call this formula the formula for the fixed rate. So I'll just call this the fixed rate formula when I refer to it later. And you need to remember this. I don't want you deriving it on the exam, but I'm explaining this, just in case. Worst case scenario, if you forget what's going on, as long as you remember the concept, you can quickly come up with this formula. Let us now talk about valuation. We move forward 90 days and interest rates have changed. CIBOR is now 9.6%, so that's 90-day CIBOR, and 270-day CIBOR is 10.4%. What is the market value of the swap here on day 90? And we take the perspective of the fixed rate pair. The notional principal is 100 million. The value is going to be the difference between the present value of fixed payments and present value of floating payments. So where do we come up with these present values? Consider the fixed payments first. We've already established that for 1 unit of currency, the coupon payment on day 180 is 0.0487, and then at the end of the year, day 360, it's going to be 1 plus 0.0487. If you discount this back using the 90-day rate of 9.6%, you will get 1.0204. And just to make sure, you should be able to calculate this discount factor. It is quite likely that on the exam you will be given the discount factor, but I'll just show you where it is coming from. This is a 90-day period. So the discount factor, which means the present value of 1 unit of currency received over here, this discount factor is 1 divided by 1 plus 0.096 divided by 4. Divided by 4 because it's 90 over 360, which is 1 over 4. When you do this calculation, you should get 0.9766. Since that's the first cash flow, we also refer to this as D1. What about the present value factor for 1 unit of currency received on day 360? Here the present value factor is 0.9276, and I'll do that calculation also very quickly. The present value factor is 1 over 1 plus the rate of 0.104 into 270 over 360, because from 90 to 360 we have 270 days. When you do this calculation, you should get D2 equal to 0.9276. So the present value of 1.0204 is D1 times this number plus D2 times this number. What about the floating payments? Here the present value is 1.0205. And where does this number come from? We've already established that for the floating rate instrument, again, the principal is 1 unit of currency. On day 180, the coupon payment is 0.045. This is based on the interest rate of 9%, which was in effect at time 0. 9% was 180-day CIBOR on day 0. So we know this payment. But we don't know the cash flow on day 360. What we do know is that the present value of this cash flow on day 180 is 1. So to come up with 1.0205, we take 1.045 and discount back using D1. D1 has been calculated before. So you take 0.9766 into 1.045 and you get this number. Now let's come to the value. We've established that for 1 unit of currency, the present value of fixed payments is 1.0204. We are taking the perspective of the fixed rate pair. So this is the payment that needs to be made. Hence we have a value of minus 1.0204. Value of received floating is 1.0205. That is a plus. That's the number shown right here. The swap value is the difference. So it's 1.0205 minus 1.0204, which is this number. We have a notional principal of 100 million. And this is based on 1 unit of currency. So you have 1 unit of currency value this. For 100 million, you just multiply by 100 million and you get 10,000. So that is the value of the swap for the fixed rate pair.